Ever wondered how guns are really made, not just shown in movies, but step by step inside real factories, with real tools by real people? Today, we're breaking down the full journey of the AR-15, from raw steel to a finished rifle. We'll show you the tech, the testing, the secrets behind its design, and why this gun became one of the most talked about in the world. Stick around, you'll never look at firearms the same way again. The birth of a legend. Every iconic machine has an origin story, and the AR-15 is no different. It all began in the 1950s when a man named Eugene Stoner, an aircraft engineer by trade, was hired by a small firearms company called Armalite. At the time, the U.S. military was looking for something lighter, faster, and more adaptable than the bulky rifles left over from World War II. Stoner took a radical idea that guns didn't have to be made from wood and heavy steel, and ran with it. Instead of traditional materials, he turned to aircraft-grade aluminum and fiberglass, cutting weight without cutting power. What he came up with was the AR-15, short for Armalite Rifle Model 15. In 1959, Armalite wasn't big enough to push it to the military, so they sold the design to Colt. And that's when things really started to move. Colt made a few tweaks and landed a deal with the U.S. Air Force. The military version was renamed the M16, and soon it was on the front lines in Vietnam. "We didn't just build a rifle, we built a platform," Stoner once said, and he wasn't wrong. While the M16 made headlines in war zones, the AR-15 quietly found a new home back in the U.S. Originally seen as a niche product, the civilian AR-15 slowly evolved. Over time, shooters started to notice its potential, not as a military tool, but as a personal one. And that's where its second life began. What started as a military rifle became something much bigger, an American phenomenon. Coming up next, we dive into why this gun took off in civilian life like no other. From gun ranges to garages, let's find out why over 24 million AR-15s are now in American hands. Why the AR-15 took over America. So how did a rifle designed for war become the most popular firearm in America? The answer lies in one word: versatility. The AR-15 isn't just a gun, it's a toolkit. With over 24 million in civilian hands, it's now found in hunting lodges, shooting competitions, and home defense setups across the country. People love it because it adapts. Want a short barrel for close quarters? Easy. Prefer a longer barrel for accuracy at the range? Swap it out. Need a new optic or grip? Bolt one on. In short, it's the adult version of Legos, except these pieces fire real bullets. From the beginning, the AR-15 was built with customization in mind. Its modular design means you can switch out parts like scopes, handguards, stocks, and even triggers to build your ideal setup. And because it's been around for decades, the market for accessories is massive. But it's not just about parts, it's also about purpose. Whether you're defending your home, hunting wild boar, or training on a competitive course, the AR-15 adjusts to the job. That's something few other rifles can offer. Even pop culture hasn't ignored it. You've seen it in movies, news headlines, and even political debates. The AR-15 has become a symbol, for better or worse, of modern American gun ownership. You don't just buy an AR-15, you build your own version of it. Next, let's leave the buzz and headlines behind and get our hands dirty. Because before any of this hits a shelf, it starts as a sketch in a few blocks of steel. Let's step into the mechanical heart of a gun and break down how the parts actually work. Understanding gun mechanics. Before we talk about machines, metal, and manufacturing, we have to understand the basic anatomy of a firearm. A gun might look like a single unit, but it's really a system of carefully balanced parts, each playing a role in making that loud bang happen. At its core, every gun has a frame, barrel, and trigger group. In older revolvers, you'd also find a rotating cylinder that holds the bullets. But in an AR-15, the action is more modern. Instead of rotating chambers, it uses a magazine to feed rounds and a bolt carrier group to load and eject each bullet. Here's what happens when you pull the trigger. A firing pin strikes the bullet's primer, igniting a small explosion. That explosion forces the bullet down the barrel. The gas released from that shot gets recycled through a tiny tube, pushing the bolt back and ejecting the spent casing. The spring inside then pushes the bolt forward again, chambering the next round. That's semi-automatic action in real time. The AR-15 uses what's called a direct impingement gas system, a design that's light, efficient, and fast. And every part of the system has to be in sync, or the gun just won't fire correctly. Guns are less about power and more about timing. Every part moves at the right moment. Now that we've cracked open the mechanics, it's time to build the real thing. In the next chapter, we'll step inside the digital brain of the operation, where the first spark of creation isn't made of fire, but of code. The CAD room. Before a single piece of metal is cut, a gun is born as a digital file. Inside every modern gun factory, engineers work behind glowing screens, building every detail in a program called CAD, computer-aided design. They create exact 3D models of each component, from the bolt carrier to the barrel threads. It's not just about drawing, it's about predicting. CAD lets designers simulate stress, heat, and pressure, showing how parts will behave before they even exist. Think of it like a wind tunnel for guns. Why is this step so critical? Because the AR-15 is modular. Every piece has to fit precisely with any compatible part from any other maker. That's a tall order in manufacturing. 1 millimeter off, and you've got a safety hazard. This is also where innovation begins. Want to shave off a few ounces? Redesign the handguard. Want better airflow? Modify the barrel profile. Before CAD, all of that required trial and error with expensive materials. Now it happens with a few clicks. We build it in the cloud before we build it in metal. Next, we move from screens to steel. It's time to feel the heat, because now the raw materials arrive and the real forging begins. Raw materials that make a gun. Making a gun starts with choosing the right ingredients. And unlike food or fashion, there's no room for compromise here. Guns endure explosive forces every time they're fired, so the materials have to be incredibly tough, but also precise. Most AR-15 barrels are made from chrome moly steel or stainless steel, strong enough to handle heat and pressure, but machinable enough to carve with precision. For the receivers, aircraft-grade aluminum is preferred. It's light, corrosion-resistant, and still strong enough to take a beating. But it's not just about strength. Metals must be consistent. If there's even a small impurity inside the steel bar, it could crack under pressure. That's why manufacturers perform strength tests, hardness checks, and chemical analyses before anything moves forward. Older guns used iron or softer metals, but those don't hold up to the demands of modern firearms. The AR-15's design demands more. It's meant to fire thousands of rounds without fail. You can't build a reliable gun from unreliable metal. With our materials inspected and approved, it's time to begin shaping them into something recognizable. Coming up next, we take that steel bar, bore a hole through its core, and carve the most important part of the rifle, the barrel. Barrel production. Once the steel has been inspected and approved, the first part to come to life is the barrel, the heart of any firearm. It's where accuracy is born and where engineering meets art. Everything begins with a long, solid bar of high-grade steel. This bar stock is cut to length, prepped, and then fed into a massive humming machine called a gun drill. It carves a perfectly straight hole down the center of the bar. This is the future bullet's path. That hole has to be exactly aligned or accuracy suffers. If the bit wobbles, even by a hair, the shot won't land where it's supposed to. But a hole isn't enough. Next comes rifling, a spiral groove inside the barrel that spins the bullet as it exits. That spin stabilizes the projectile, keeping it flying straight, just like a quarterback throwing a tight spiral. To make that rifling, the barrel goes through a process called hammer forging. Here's how it works. A mandrel, which is a steel rod with the reverse image of the rifling, is placed inside the barrel. Then massive hydraulic hammers pound the steel around it, thousands of times a minute. The result is a barrel that's not just cut, but formed. This makes it stronger, more uniform, and more durable. The barrel is where the battle begins and where precision is won. After forging, the barrel is heat-treated, polished, and checked for any defects. It's tested for straightness and surface finish. Only the best pass inspection, because the barrel is where the bullet meets physics and there's no room for error. With the barrel completed, we now need to give the rifle its structure. It's time to carve out the brain and backbone of the AR-15. CNC and robotics at work. At this stage, raw aluminum blocks and steel billets are transformed into the bones of the rifle using some of the most advanced machines in modern manufacturing. Enter the CNC machine, short for computer numerical control. Think of it as a robotic sculptor that works with micro-level accuracy. Engineers load the aluminum receiver blocks into the machine, and it goes to work, shaving, carving, and drilling, all controlled by that CAD file we talked about earlier. These machines run around the clock, slicing through metal with such speed and precision that even a single misplaced decimal point in the code could destroy a part in seconds. That's why everything is tested before production starts. For more complex parts, like charging handles or intricate handguards, manufacturers use robotic arms and plasma cutters. These tools don't just work fast, they work consistently. One of the key machines used is the Sackett robot, a high-end polishing unit that gives each part a clean, uniform finish. That finish isn't just for looks. It reduces friction, prevents rust, and keeps the gun running longer. To keep everything cool, a liquid coolant system flows over the cutting surfaces, keeping the machinery from overheating as it grinds through metal. The smell of oil, the whir of motors, the hiss of pressurized air. This is the sound of modern gun building. Every part is shaped by code, cooled by science, and polished by precision. Once the body is cut, carved, and ready, it's time to bring all these parts together. Next, we step into the most hands-on part of the journey, assembly. Assembling the firearm. With every component now manufactured and inspected, it's time to put the AR-15 together. And while machines may dominate production, the final touches still rely on skilled hands. The assembly floor is quieter than the machining rooms, but the focus is intense. Gunsmiths work at long benches surrounded by bins of springs, pins, and carefully labeled parts. The process begins with the lower receiver, the part legally defined as the firearm. Into this go the trigger group, safety selector, magazine catch, and buffer tube. Next comes the upper receiver, which houses the bolt carrier group and barrel. Here, the precision of the earlier steps really shows. Parts must fit together with no gaps, no forcing, no errors. A fraction of a millimeter too loose or tight, and the rifle won't cycle properly. Some parts are installed by torque wrench, others are tapped gently into place with brass hammers. Where needed, welding or adhesive bonding ensures durability. Certain tasks, like aligning the gas block or tuning the trigger pull, require hands-on experience. Even with automation, human feel still matters. Once the core is assembled, the rifle gets its finishing touches: grips, stocks, muzzle devices, and optional optics. Every build is slightly different depending on purpose, from tactical setups to competition rigs. The machine makes the parts, the gunsmith makes the rifle. With the rifle assembled, we move from production to validation, because now it's time to make sure it actually works. Factory quality trials. No AR-15 leaves the factory without proving itself. Before it's boxed, shipped, or sold, it has to survive a gauntlet of performance tests. First is the dry fire test, a mechanical check to ensure the trigger works, the safety engages, and the bolt cycles smoothly. It's like checking the heartbeat of the rifle before giving it ammo. Then comes the indoor range test. Here, each rifle is loaded with 10 live rounds and fired down a controlled lane. Engineers check for accuracy, cycling issues, and proper ejection. Targets are measured down to the millimeter. Even one misfire sends the gun back for rework. But the real test happens outdoors. Rifles are taken into a simulated combat environment. Mud, dust, rain, and heat. These combat capability tests push the rifle to perform in less than perfect conditions. Will it jam? Will it overheat? Will it keep firing under pressure? Finally, there's the durability trial. Brutal, unforgiving, and essential. Rifles are submerged in water, baked in heat, and coated in fine grit to mimic desert dust. Then they're fired again. A rifle that survives this is ready for anything. You don't test a gun to see if it works. You test it to see if it ever fails. Once a rifle passes all phases, it's cleared for release. But one final safeguard remains, ensuring it's built not just to perform, but to last. The gatekeeper of safety. Behind every dependable firearm is a wall of quality control that no defective part can slip past. From the moment raw material arrives to the final test fire, every component is checked, measured, weighed, and verified. These checks are governed by strict specifications: surface finish, hardness, tensile strength, and more. If a part is even slightly out of spec, it's scrapped or reworked. Quality inspectors use calipers, micrometers, X-ray scanners, and sometimes even lasers to measure. Tolerances down to thousandths of an inch. It's a blend of science and discipline. Some factories test every single part. Others use batch sampling with statistical analysis to find trends before they become problems. The goal? Reliability and safety. A gun isn't like a car or a phone. It can't just mostly work. It must function perfectly. Because when it fails, lives are at risk. If a rifle passes its final inspection, it gets its stamp, literally. A serial number is engraved, documentation is completed, and the gun mount is packed for sale. But if anything fails, the gun doesn't ship, period. You don't sell trust, you build it, one flawless part at a time. And that's how an AR-15 earns its place on the shelf. But what makes this rifle truly different is how it continues to evolve after it leaves the factory floor. Coming up next, we explore the extensions and add-ons that make the AR-15 unlike any other firearm on the market. What makes it modular? AR-15 extensions explained. The AR-15 is more than just a rifle. It's a platform, a blank canvas, a machine built to be modified. And that's what truly sets it apart from nearly every other firearm on the market. Most guns come as is. You get what's in the box. But the AR-15? That's just the beginning. Once someone owns one, they often find themselves in a world of options. Optics are usually the first upgrade. You can go simple with a red dot sight for quick target acquisition, or step up to a magnified scope for longer range precision. Some go even further and add holographic sights, which project a floating reticle over the target like something out of a video game. Next up are grips and handguards. These aren't just cosmetic. A vertical grip helps you control recoil and stay on target. Free-floating handguards not only improve stability, but allow shooters to attach flashlights, lasers, or bipods, all with modular rails. Then there are muzzle devices. A flash hider hides the blast at the barrel's end. A muzzle brake reduces recoil. And a suppressor, it lowers the noise, making it easier on your ears and the neighbors. Even the stock can be swapped out. Whether it's a lightweight collapsible stock for maneuverability or a heavy-duty fixed stock for long-range control, there's a setup for everyone. Buffer springs, triggers, charging handles. Everything is up for change. With most rifles, you adapt to the gun. With an AR-15, the gun adapts to you. This level of personalization is why many owners say owning an AR-15 isn't a one-time purchase. It's a journey. You don't just shoot it, you tinker, fine-tune, and upgrade it to fit your exact needs. But with great flexibility comes great responsibility. That's where the next part of our journey begins. Understanding what it takes to own one legally. Buying and owning a gun. As much as building and customizing a firearm is a technical process, owning one is a legal one. In the United States, gun laws vary depending on the state, but there are some common rules, especially when it comes to the AR-15. First, there's the matter of age. In most states, you must be at least 18 to purchase a rifle like the AR-15. From there, you go through a background check, a system designed to screen for criminal history, restraining orders, and other disqualifying factors. Once approved, the rifle must be registered under your name. Every gun has a serial number etched into the receiver, and that number is tied to the paperwork you file when you buy it. This is how authorities can track where a firearm came from, should anything ever go wrong. And then there's the big one, storage and safety. Having an AR-15 means you're responsible for keeping it secure. Many states now require gun safes or locks. Accidental discharges or thefts that lead to crimes can carry legal consequences for the owner. Some accessories and configurations also fall under specific laws. For instance, adding a short barrel or a suppressor may legally reclassify the gun as a restricted item. requiring extra paperwork through the National Firearms Act, NFA. Owning a gun isn't just a right, it's a responsibility. Failure to follow the rules can lead to serious consequences, from fines to felony charges. The point isn't to scare, but to stress that legality is part of the ownership experience. It's what separates a responsible owner from someone breaking the law. So with the gun built, tested, customized, and legally owned, what's next? To wrap up this journey, we zoom out. Because this story isn't just about one gun, it's part of a much bigger timeline, one that stretches back over 1,000 years. 1,000 years of firepower. To truly understand how far we've come with modern firearms like the AR-15, we need to look back, way back. The story of guns begins not in America, but in 9th century China, where early inventors discovered the explosive power of gunpowder. Those first weapons looked nothing like today's rifles. They were little more than bamboo tubes packed with powder and a metal projectile. But they worked, and they changed everything. By the 1300s, muskets had made their way into Europe. These early firearms were slow, inaccurate, and heavy, but they offered something swords couldn't: range. And that advantage changed the face of warfare forever. Fast forward a few hundred years and the revolver enters the scene, giving soldiers multiple shots without reloading. Then came bolt-action rifles, semi-automatics, and eventually the assault rifles of the 20th century. Each version pushed the limits of speed, accuracy, and ease of use. The AR-15 is the result of that centuries-long evolution. It's lightweight, accurate, customizable, and dependable. But it's also symbolic. It represents the blending of military engineering with civilian technology. It's both loved and debated, praised for its design and criticized for its accessibility. The AR-15 didn't appear overnight. It's the product of 1,000 years of human innovation and human conflict. What started as smoke and sparks in a bamboo tube is now a modular machine of stunning precision. And through it all, guns have shaped history, not just in battlefields, but in culture, politics, and industry. As we close this journey, one thing is clear: understanding how guns are made isn't just about metal and mechanics. It's about people, progress, and the choices we make with the tools we build. And that's the real story behind how modern guns, especially the AR-15, are built from the ground up. If you learned something new or just enjoyed the journey, hit that like button and subscribe for more deep dives like this. Thanks for watching, and we'll see you in the next one.